Okay, I'll be sharing my screen. I wrote this on paper. Okay, so it starts out, what is the prior probability? So what's the probability that hypothesis 1 is true? Hypothesis 1 is that you click on link 1 and it's course A. So since there are 2 links and you have no information about which link is which course, you have a 50% chance of clicking course A. There's 1 link you're clicking divided by 2 courses, 50% chance or 0.5. What is the value of the likelihood, P, the probability of a scenario given that hypothesis 1 is true? So this is the scenario would be the chances of seeing 6 people. That's what we were given as our scenario, given that link 1 is course A, because that's hypothesis 1. So because you have a 90% chance that there's 6 people in course A, or you are 90% sure that there's 6 people, this means that if link 1 is course A, you have a 90% probability that there are 6 people in that class. So 90% or 0.9. So then this is the normalizing term, the probability of the scenario. So this is calculated by this equation here. So this part, we already calculated this. It's the probability of seeing the scenario given hypothesis 1 is true, 0.9. We already calculated this as well. The probability that you click course A is 0.5. This we have not calculated. This is the probability of seeing the scenario given that hypothesis 2 is true. And hypothesis 2 is that link 1 is not course A, it's course B. So what are the chances you see 6 people? Well, you're 70% sure that there are 6 people in course B. So there's a 70% chance that there will be 6 people if you're on course B. So this here, you can use you can calculate by using the probability of hypothesis 1 being true. You're going to use 1 minus that probability, which is 0.5, equals 0.5. And this logically makes sense as you have a 50% of chance of clicking each course. So you multiply these, and add them together, you're going to get 0.8 or 80%. The last question is the value of the posterior probability. So the probability that hypothesis 1 is true, given that you see 6 people in the scenario. This is calculated using this equation here. Now, we already found these numbers, 0.9 and 0.5, and these can easily be filled in here. We already found these as well. So this would be the probability that you see the scenario given that hypothesis 2 is true, 70% or 0.7. And this we already calculated as well. What's the probability of hypothesis 2 being true? It's going to be 0.5. I wrote this equation here. And once you multiply these together, you get 0.45 over 0.45 plus 0.35, and it's going to give you 0.5625, or about 56%.